There are many misconceptions about welding. Some people think it's a magic fix for anything. Others believe it's simply a matter of gluing metals together, and some imagine it involves massive flames and sparks. But the truth is, welding is a precise and complex craft that requires skill, knowledge, and attention to detail. In this video, we will explore the principles, components, tools, and processes of how welding works. Welding machines are the unsung heroes of modern manufacturing, enabling the creation of everything from skyscrapers to smartphones. Yet the occupation has been plagued with a lot of stereotypes and misunderstandings. One of them is that welding is a simple and straightforward process. For whatever reason, there is a misplaced theory that welding is an easy job. While it's true that almost anyone can learn to make basic welds in a few hours, a seasoned welder brings expertise in creating joints that withstand stress, maintain visual appeal, and hold up to the test of time. Much like making sushi, achieving high-quality welding results requires extensive training and hard work, regardless of whether a welder is using stick, MIG, TIG, or torch. We'll discuss these in depth shortly, so don't go away. Another misconception is that welding uses a lot of fire. Many people enjoy the scenes in How the Grinch Stole Christmas, where little Grinch smashes a bunch of family jewels and welds them together using an open flame. This depiction reflects how Hollywood often portrays welding, with lots of fire and burning metal. In reality, the most common type of modern welding, arc welding, doesn't use fire, but rather the power of electricity, similar to lightning. Both lightning bolts and welding arcs show parallel characteristics, such as the fact that both arcs follow the path of least resistance. Therefore, a more accurate depiction of welders we'd prefer Hollywood to portray is that of Zeus, the mega-ripped Greek god of lightning. Safety gear optional, only for him though. The third misunderstanding is that welders can weld anything. Unfortunately, not all materials can be welded effectively. Some of the materials that can be welded include steels, stainless steels, aluminum, nickel, copper, titanium, cast iron, and all of their alloys. Remember, an alloy is just a new metal made by combining two or more metals, like copper and tin, to make bronze. Most welding done today falls into one of two categories: arc welding and torch welding. Arc welding uses an electrical arc to melt the work material and the filler material, in this case a welding rod, to create joints. In this process, a grounding wire is clamped to the welding material. An electrode lead is then placed on the material to be welded. The electrical circuit is completed when the welding rod touches the work material. This type of welding is essentially a controlled short circuit. This arc melts the work pieces along with the filler material that helps join the pieces. An electric welding machine is generally considered to be a high amperage device rather than a high voltage device. Welding machines typically operate at relatively low voltages between 15 and 45 volts, but require high amperage to create the heat necessary for welding. The high amps are essential to melt the metal and fuse the materials together. The amp requirements can range from a few dozen to several hundred amps, depending on the type of welding and the thickness of the materials being welded. Feeding the filler into the welding joints takes steady hands and an eye for detail. As the rod melts, the welder must continuously feed the filler into the joint using small, steady back and forth motions. These motions are what give welds their distinctive appearance. Going too fast or slow, or holding the arc too close or too far away from the material can create poor welds. Shielded metal arc welding, or stick welding, gas metal arc welding, commonly known as MIG or metal inert gas welding, and gas tungsten arc welding, often called TIG or tungsten inert gas welding, are all examples of types of arc welding. Each of these methods has unique advantages and drawbacks. For example, stick welding is inexpensive and easy to learn, but is slower and less versatile than the other methods. On the other hand, TIG welding is difficult to learn and requires a complex welding setup, but it produces high-quality welds and can work with materials that other methods can't handle, like stainless steel and aluminum. Torch welding represents another popular welding method. This process typically uses an oxyacetylene torch to melt both the working material and the welding rod. The welder controls the torch and rod simultaneously, allowing for significant control over the weld. While torch welding has become less common in industrial settings, it is still frequently used for maintenance and repair work, as well as in artistic sculptures. Despite the modern machinery involved in welding today, the process itself is not new. Welding has been around for thousands of years. Early examples have been discovered in various locations from Ireland to India, dating back to the Bronze Age. These ancient civilizations lacked the sophisticated tools and machinery that modern welders use. So how did they manage to weld? The process they used is known as forge welding. To start the process, blacksmiths would heat the metal until it was bright red in color, but still not at its melting point. The blacksmiths would then overlap the two pieces on an anvil and pound them together. Forge welding has multiple limitations. Only relatively soft metals can be forge welded, and the process is labor intensive. In places without electricity, however, the process is still used. Forge welding was the only game in town until the 19th century. The Industrial Revolution brought about significant advancements that propelled welding forward rapidly. Research on electricity yielded electrodes and electric arcs. Rudimentary torches were developed by mid-century as well. Both discoveries would play heavily into the welding methods of the next century. By the late 1800s, many of the pieces were in place to make welding a driving force in manufacturing. Still, the methods of this era were not perfect. Oxidation, the process of metals bonding to the oxygen particles in the atmosphere, occurred during the welding process that would make welds porous and brittle. Such welds posed a grave risk to workers. During the period from 1895 to 1905, for instance, poorly made boilers exploded daily, causing thousands of deaths in the process. Clearly, there was an urgent need for better welding methods. By now, you may have gathered that welding isn't necessarily a complex process. You can grasp the basics of several welding methods in just a few hours. However, similar to chess, welding is an easy-to-learn yet challenging-to-master profession. Professional welders face a multitude of variables to consider in their work. Despite the complexity of their tasks, they only require 3 essentials to get the job done: a welding rig, materials to weld, and proper safety equipment. Safety is very important in welding. If you've ever seen welding in person, you can attest to the blinding brightness the process creates. Looking directly at a weld site without protection can produce what is known as arc eye or welder's flash, a painful inflammation of the cornea that feels like getting sand in your eye. No wonder that a good welder's mask is a prerequisite for any welding outfit. Welding masks come in various styles. Simple masks have a darkened panel through which the welder looks during welding. More advanced masks have a auto-darkening capability that adjusts as the welding site becomes brighter. In addition to the intense brightness, welding can produce temperatures of up to 10,000 degrees Fahrenheit or over 5,000 degrees Celsius, and showers of sparks. Therefore, heavy-duty gloves and a long-sleeve, fire-retardant shirt are essential protective gear for welders. Lastly, proper ventilation is crucial when welding. Welders are exposed to harmful substances such as lead, mercury, and carbon monoxide from the welding fumes. Ventilation systems such as vent hoods are essential to prevent these fumes from accumulating in the workplace and posing health risks to the welders. After ensuring safety, the next process is ensuring quality of work output. The process of joint preparation is perhaps equally important to producing strong welds. It begins with ensuring that work materials are clean and free of grease, dirt, and dust. However, this is just the initial step. There are various types of joints used in welding, such as edge joints, lap joints, T-joints, and butt joints. Choosing the appropriate type of joint for the specific welding task is essential to achieving a higher quality weld. Each type of joint offers different advantages and is suited to different applications, so selecting the right one contributes significantly to the overall weld quality. Knowing which joint to use in which application is one thing that separates amateurs from the professionals. Once a weld is in place, the welder checks its quality in several different ways. Visual inspection is often the first step, revealing issues such as improper welding speed, too high or too low amperage used, cracks, or other defects. Additionally, welders may employ NDT or non-destructive testing techniques like magnetic particle testing, liquid penetration inspection, ultrasonic testing, X-ray inspection, pressure testing, or other methods to further evaluate the weld integrity. Destructive testing, although it destroys the weld being examined, is also commonly used to assess the weld quality thoroughly. Regardless of the testing method employed, ensuring welds are strong and durable is crucial for the intended application. So what did we learn today? We learned welding is combining two metals together, usually with another metal as a filler. That people have been welding for as long as metal has been around. There are two different kinds of welding, arc welding and torch welding. Arc welding can be done by stick, MIG, or TIG and employs electricity, kind of like controlled lightning. Remember Zeus? Torch welding uses gases to melt the metals instead of electricity. And always wear protective gear when welding, especially a face shield. What are your thoughts and experience with welding? Let us know in the comments below. If you enjoyed the video, please share it with a friend. Don't forget to like and subscribe to our channel for more insightful content weekly.